Hi, and welcome to a video on how to get started on the project for Module 4 in our C++ class, which is the Crowdsourced Quilts project. I think the name will become more obvious to you as we get a little farther along. The way to start with this project, first and foremost, is to look in the canvas, as we are here, and look at the resources that are provided. This one, the one that says Crowdsourced Quilts, that's an assignment, and that's where you'll end up submitting your code. You can click on it and look at it if you want. It doesn't automatically submit anything, but that's what it does. The next element is Crowdsourcequilts.pdf. This is a set of instructions for the project. Yeah, they're a little long and a little complicated, but we're going to walk through some of them, and I think you'll find it a lot of fun. Quilt part 1.zip is some source code you need to get started. I give you some source code in this project, and you add to it and complete it by creating additional classes. That's one thing that C++ does well, is it lets you build up a larger program out of smaller pieces by using classes. And in fact, in the part B or part 2 of this project, we'll actually put together classes developed by different students into one final project. And I think you'll find that interesting. There's some example quilt block shapes. We'll go over those in a minute. Just shows you some of the patterns you can make in this graphical program. And then there's a discussion forum where you can post your output. So this is another one of those projects where we're going to be collaborating a lot in the discussion forums, sort of like you did in the scenarios. So first of all, let's take a quick look at the instructions. So I'm going to open up the PDF, or download the PDF, and open it. Just I will. Okay, if I click on the right thing, it will open. I'm going to download it. There is a PDF viewer built into Canvas. You can use that one if you want. Usually works better if you download and look at the result. But here is the instructions, and there's quite a few instructions because there are a lot of steps. The steps are not hard, but there are a number of steps to this project. So some of the things that you'll learn in the project, which I think are really important, this project actually combines C and C++ into a single project. So when you took the C class and you wondered, well, how does that work with C++? Actually, you can put the two together, and when it makes sense, you can do that. The C in this project comes from some C code I had for the C class, which I knew already worked. So I'm going to incorporate it into the classes we create in C++ because I want to be able to reuse as much code as possible, especially when it's been tested. You'll see how to build a project from multiple source and header files. Probably all of the projects you built so far have been, a single file that had everything in it. And now we're going to actually break it apart and have separate header files and .h files and implementation files, .z files for each class, along with a number of other files that you'll need. You'll put those all together in your development environment, be it Visual Studio 2019 or VS Code or Xcode or CodeBlocks, and see how that all builds together to make one executable project. You will add to an existing project framework, so instead of just writing this from a blank screen, you'll actually be writing code that fits into code that I supply, fits into a framework. And that's actually very realistic in terms of the kind of tasks you're likely to be asked to do as a beginning programmer. It's not so likely that you'll write so much stuff from scratch as it is that you will write programs and code programs and fit them into existing code that forms a product. You'll see the difference, if it's not clear to you already, between declaring a class, which you do in a .h file, and defining the class, which you do in a .cpp file. And of course, you invoke the class. That's where you actually instantiate and run it in main. Well, this is another SVG graphics example. So we're going to take advantage. We're going to leverage the ability of your browser to display graphics that are in the SVG HTML language. And so we won't need any actual Graphical library will just produce SVG HTML, load it into your browser, see what it looks like. This project has a good example, practical, simple example of inheritance. That's the ISA relationship. It also has a practical example of containment. That's a HASA relationship. It's important to understand the way that classes and objects work together, and these relationships are key to that. You'll also see how polymorphism, which is one of those words that scares everybody to death about C++, how polymorphism lets you use child classes as if they were the parent class. Well, that sounds very abstract, but what that means is that when you create a class to make a specialized quilt block, you can add it to the quilt and you can treat it as if it were any other block. So it's actually a very convenient way to have a framework formed by the parent class and stuck your code into it using derived classes. So that's the basic goal of the project. You should read the rest of the PDF and try to understand the instructions and ask questions where you don't. I'm going to go back to the module, and we're going to go ahead and download the sample source code. Now, this is not all of the source code for the project, but this is enough to get you started and make sure that your development environment is set up correctly to build a project from multiple files. Sometimes it takes some tweaking, particularly in Visual Studio. Okay, so I'm going to download this zip file. I'm on a Mac, so this may look a little different on Windows, but it's, you know how to uncompress or unzip zip files on Windows, I'm sure, so that really shouldn't be a problem for you. I'm just going to save it. It's going to end up in my downloads directory the way my system is configured. So I'm going to go to that folder and I'm going to unzip it, which in the Mac just means double clicking it. In Windows you would select extract all, I think, and creates a new folder, and in that folder already are some files that you need. There's a number of files there. There are 3 .h files. Those are files that declare classes and functions that we need. And there are 3 C++, that's the .cpp files, for the classes that we're implementing, and 1 .c file, which is a set of functions that are used to actually write the SVG code out. So there's the mixture of C and C++. We need to get those into a project in an IDE so we can build them all together. I'm going to use Visual Studio Code, but you may choose to use something different. The way you add the files to the project depends on the IDE that you're using, but in general, you can drag and drop files onto the project in your IDE, and because they end in .h or .cpp or .c, your IDE will automatically drop them in the right places. So here's Visual Studio, and I'm going to open that folder I just downloaded. Here's what the project looks like when it's completely set up in VS Code, at least on the Mac. The way you set it up in Visual Studio is a bit different, but you'll end up with many of the same files. Notice I have all the source files I downloaded, the H files and the CPP and C files. I also have a main.cpp that kicks the whole thing off. And there's an additional file called a make file. Now, you won't see this in Visual Studio 2019, but it does in fact exist. And Visual Studio takes care of that for you. CodeBlog takes care of that for you, so you don't actually see it. Here in Visual Studio, you actually see that file. So that's the file that actually controls how your program is built. So let's look through the code briefly and see what we have. Starting from main, which is really the best part in understanding this, you can see main includes all of the H files that we supplied, and there's also some convenient color definitions that are set up in main. But main itself is very short. All it does is run the begin HTML SVG method, which is over in svgcreator.c, instantiates a new class. This is the class I supply. You're going to make your own class here with a different name and a different pattern and different colors. And then tell that patch to display itself. And then end HTML just closes off the HTML we're creating, the SVG HTML, so that it will be valid for a browser. So I'm going to compile this, and again, you can compile it by hitting a button probably in your IDE. I'm going to compile it the old school way because I like working at the terminal, and it's a lot easier for me in this environment. So this is how you build it when you have a make file and you're doing it at the command line. So make will compile all these files and spit out an executable program. And you can see the actual command that was generated, G++. That's the GNU C++ compiler. Your compiler might be different. You might have Clang, or you might have some other C++ compiler, but this is the one I'm using. There's one warning, which is from mixing C and C++. We're going to ignore that because it's actually not currently a problem. So now I should have in the bin subfolder, and right here you can see it, a file called main, and that's actually the executable file that was generated from compiling this. So I'm going to run that file by giving a path to it here in the terminal. And when it runs, the output is the HTML that you see here. So I'm going to highlight that. And sometimes this is where folks get confused, because the steps are not hard, but there's multiple steps. Compile the program, make sure it compiles, run the program, take the output from your program, and paste that output into either another file that you open with your browser, or a shortcut that I really like to use, which is, I think, much easier, is to go to W3 Schools, and in addition to having a lot of useful information about SVG graphics, they have a cool little feature called Try It Yourself. If you click Try It Yourself, there's their example, which draws one yellow circle. I'm just going to replace their example with my example. I'm going to hit Run. Okay, there's one quilt block. It's made up out of 4 squares of 2 different colors. Colors you may recall in main I was using aqua and brown. That's what they look like when they actually render. So let's see how the code actually did this. So back to Visual Studio, and in the code that actually ran, if you look in 4patch.cpp, this is the code that implements the 4patch class. 4patch class extends block, so it's kind of block. And here, I set the colors, and I actually drew the 4 squares you see in the output using these rect commands, which come out of svgcreator.c. So you should be able to build this without any changes to the code whatsoever. And building this and running it just shows that your development environment is set up correctly. You've got your H files in include, you've got your CPPs in C in source, and you have the correct options set in your compiler. So that's basically that's the first part of step 1. The next step is to actually look at my example, the 4patch.cpp, and make your own block following this example. So if we look at the header file for this, you'll see it's a derived class. 4patch is a kind of quilt block that is derived from the parent class block. And it only needs a couple methods. One is it needs a constructor that says how wide it is, how high it is, what the background color is, and what each of the 2 square colors are. There's a method called render, which is where most of the work is done. That's what actually draws the square in SVG. And there's an overloaded version of render that lets you specify where on the screen, X and Y, to draw the block. So if you look at 4patch.cpp, you'll see here's the constructor, and all it does is initialize a bunch of instance variables primarily. And render is where all the work gets done. Render is where you figure out, using arithmetic, it's not really any higher math, exactly how to make those nice symmetrical squares. So get this part to work, get this part built, post questions if you can't get it to build and run, and then start working on your own block.